Hi, and a warm welcome to all our viewers of ESG TV once again. My name is Raj Arya, and today we'll bring you another webcast interview on all things regenerative, where last week Andrea Di Rosario gave us insights on renewable and clean energy, in particular green buildings. And leading on very nicely from there, this week our topic today is building for a better planet with our special guest, Pek Har, Director of Web Structures, Sendirian Berhad. Pek Har, thank you for being with us today.
Thank you, Raj, for inviting me and Web Structures to this. And a very warm welcome to everyone who's listening.
Right, fantastic. Now, before we dive into the topic at hand, obviously our viewers would like to have a feel in terms of who you are and your journey thus far. So could you just share with us a bit about yourself as well as how Web Structures came about?
Okay. It's a long story, as I said, but I'm going to make it really quick, okay? When I was a kid, pretty long ago, I'm a physics, I was always obsessed by physics and science. So after a long journey, I became a structural engineer, but I wasn't interested in it because I found the industry pretty boring. And to be very honest, I kind of retired at the age of 37, okay? Because I didn't want to do engineering anymore. So I fast forward very quickly. About 8 years to 9 years after that, I met Dr. Hossein Razai, who founded Web Structures in Singapore in 1996. And a mutual friend thought that we should work together. At that point in time, I wasn't working as an engineer. I had laid off engineering, burnt my books, and left it there for 8 years. Yeah. So I met Hossein, and I found him to be intelligent, right? And he was very clever because he spoke to me about quantum physics and the concept of a god and all that instead of engineering. Anyway, to cut a long story short, we decided to give each other a chance to see if we could work together, and that was in the year 2004. So we started Web Structures in Kuala Lumpur with one person, me, and today it's 2020, and we have built more than 10 buildings around the Petronas Twin Towers, some of them like Troika, right, the Grand Hyatt Hotel, the Plaza EQ. And what we do is that we are structural engineers. We love to design buildings. Let me just explain that very quickly. Architects design the shape of buildings and how it functions, the layout plan and how people habitat it. The architect is supported by a team of people, for example, the mechanical engineer who makes sure that the air conditioning works and all that. And what structural engineers do is that they make sure the building stands up. That is it in a simple terms, right? So that they can withstand the forces of wind, the gravity forces, the loads on the building, earthquake, and stuff like that. More than that, we are known as structural engineers who do what we call fusion engineering. We work very closely with architects like Norman Foster from the UK, Zaha Hadid, also from London, Richard Rogers, and a whole host of engineers all over the world. We are driven by this passion to design buildings which take as little as they can from the resources of the earth. We don't want to waste material. And yet we want to create buildings and spaces which are beautiful, which give joy to the people who use them. I think I'm like talking too much.
No, in fact, you answered quite a fair bit in terms of where I'm coming from, because obviously a lot of people who have thought of civil engineers, mechanical, aviation, aeronautical, sorry, but not many would have thought of structural engineers. And it seems like they play a very, very important role because we see so many tall buildings and skyscrapers in all the major cities around the world. Isn't that correct?
Okay, I think the reason why people don't think of structural engineers is that generally structures don't fall down left, right, center, and every day that you read about it. They only think of how building stands up when it falls down, like we have, or some disaster, like we have
Highland Towers.
Highland Towers, there was a landslide. It wasn't the structure,
okay.
Yeah. like Highland Towers, or long ago that New World Hotel or something in Singapore that just collapsed, right? So to be very honest, that viral video that went viral about a year ago, yeah, on a rainy, dark evening in Kuala Lumpur, it went viral because somebody who was stuck in the traffic jam said, "Don't come to KL. There's a huge traffic jam because there's this building that is going to collapse near Pavilion." And that building is actually the 8 Conlay building, which is under construction. And Work Structures is the structural engineer for that building. And that building is going to be the tallest twisted twin towers in Asia.
Impressive.
Yeah, so it's not that, you see, very interestingly, it's not that we architects purposely design buildings just because they like a curvy form or a form that looks like it's going to fall down. That's kind of frivolous. Yeah, but very often structurally, buildings that are curved, organic, and follow Mother Nature. I mean, you don't get a straight tree, right? Most trees are like organic and curvy and all life forms. If we were to look at biology and if we were to look at Mother Nature, and you can learn a lot from it, even in this day of advanced computational dynamics. And you often find that a curved building stands up better than a straight building.
Right. Now, moving to the topic at hand today. Now, as we all know, building buildings has been going on for more than a century. But it looks like now we are trying to move into something which is deemed more sustainable. So, how do structural engineering play a significant role in terms of sustainability in the bigger sense of things?
If I may, I think I need to, before I answer that question, I need to go back to what you said before you asked the question, Raj. Because the thing is that you said that it is only now that buildings are beginning to be sustainable. That's not true at all. To be very honest, we learn more from the past than we learn from our current peers, or with due respect to everyone, you know. For example, in the past, when people before the 20th century, before the advent of great machines, powerful machines, and all kinds of stuff, human beings had to work with nature. For example, in Japan, right, they built walls not with concrete, but they built walls with mud and straw. Yeah, because that was the material that they had on the site, and they don't have like huge trailers or bulldozers or whatsoever to cut stuff from far away, right? So so actually that's a lot more sustainable, because actually going local in terms of material is a lot more sustainable than going global. For example, why would you want to line the toilets of a high-rise building with marble that is cut away, from a mountain in Italy, right? Why don't we just use the materials that we have on the site, and local material that will reduce the carbon footprint of transportation? And therefore, I think that before the 20th century, people were a lot more sustainable in that way, right? Okay, what is good? Now we fast forward to today, to your question. In a way, because of the excesses of the 20th century, and over the last 100 years, buildings are responsible for 1/3 of the CO2 emissions on planet Earth. That's a huge sum. Yeah, because in the 20th century, human beings learned the power of great energy. We drill oil from the seas, and we use all this energy to run our machines. And so if the course of a big river interferes with what we want to do, then we said, never mind, let's change the course of the river. Let's build a dam. We can flood the forests and create energy, hydroelectric energy, right? But in doing so, we were so enamored in a way with the power that we have over the earth. And if we don't, and we want to take over the jungle, we can just like get rid of the habitats. We get rid of the fish when we reclaim land and dredge sand from the sea. And then we're left with this world that is that today we realize, oops, human beings are also one of the species, one of the the fish and all, we have to live, we need to share the same home, the planet Earth, with this. And if we deplete the Earth and our home of all these resources, then we also suffer a very bad fate as a human race. And what happens today is that scientifically and quantitatively, we have developed tools like computer modeling tools, which are capable of measuring the consumption in a real-time scale, electrical consumption of a building, how much water it consumes, and then we are saying, okay, let's not consume so much. We are consuming too much. So let's use more natural ventilation. Let's find ways to extract or recycle the heat from air conditioners and use that heat to run pumps that can actually reduce the energy load. Or we put photovoltaics on the roof and the facades of all these buildings. So these are we have all kinds of tools like LEED standard, GPI, and all that. But this has to be, it is actually good that we have this, and it's actually good that authorities and developers, they are encouraged by tax rebate and financial returns to incorporate this and get a rating like a LEED platinum rating, or in Malaysia Green Building Index rating and all that. Yeah, but it doesn't have much meaning if this is just like a tick box item. We just tick off that we have done this, we've done this, and so we get a goal, right? I think what is very important is that we need to develop within each individual a genuine care for how they live their life, how they go about doing their things, and that in that way is more sustainable. I mean, I think at this moment, to be very honest, we are more in a tick box kind of system, and we need to nurture or develop or somehow inspire this greater goal of making a part of everyone's consciousness.
Right. No, what you say actually makes a lot of sense there. Now, how do you engage with developers, for example, perhaps web structure, to influence them in terms of taking this more better path, greener path, as compared to otherwise? Because end of the day, for them, it's always about bottom line, dollars and cents. Isn't that right?
Yes, that's right. And to be very honest, it is actually very easy for a structural engineer to do that. Very simple. You see, structural engineers, when we design buildings, right, we are dealing with materials which are like structural steel, concrete, steel bars, some carpentry, formwork and all that. Now, material, there's a material cost, right? Then there is a labor cost, correct? So first and foremost, when we spend less material, that means if we use our innovation and we use our creativity and we use our know-how with the tools that we have, and we come out with very lean and very inspired and creative structural design, first and foremost, we save material. We are saving the tonnage of concrete that we are using. We are saving the tonnage of steel that we are using. So that's a direct cost benefit. Your construction cost will be less. Okay, like the structure cost is about 25% of the cost of an entire building. So if you can do like a 5% savings in that, is humongous, considering that a lot of buildings are like hundreds of million, high-rise buildings, right? Okay, so that's material. And then number two, if you develop it, if you design the building in a manner that takes into account how it's going to be built, right? Then you reduce the cost of labor, right? So of course, in Industrial Revolution 4, people talk about things like modular construction, building information modeling, and all that. So, but it's not, these are just tools, okay? But more important to the point is that we want to design such without fat. It's all of it. Sustainability is very often just about cutting the fat. So you cut the fat from your design. And a lot of structural engineers, they fear to make it very lean. Why? Because all fear comes from perhaps a lack of understanding, a lack of depth of understanding of the performance of the building. So in web structures, what we do is we use our tools and we use our creativity to totally understand the performance of the building, whatever the shape, whatever it is. And the thing is that once you understand the performance, it's like understanding your own body. You know, like you understand yourself. Maybe your left knee is a little bit weaker than your right knee. So you know you got to be a bit careful with your left knee, but you can put more weight on your right knee. So in that way, once we understand the building, we can just trim down all the materials and we can make the building a lot more buildable. That's the correct word, such that the contractors can build it in a much more easy way. And so it's so easy to convince the developer because you are saving them material costs, you're saving them labor costs that shortens the construction time.
Yeah, always help when you can speak the developer's language, which is profit margins and of course the bottom line. Now I'd like to move on with regards to the analogy which you use. I like the way you say that sustainable development is like cutting off the fat. Now, how about adding on a little muscle to that in terms of regenerative development? Now, that is obviously a new terminology that's going around. What does that mean to you, regenerative development?
Okay, for buildings, what regenerative buildings or regenerative project means is actually this word that's bandied around a lot, but I want to give it a more precise meaning, okay? The word is net positive, net positive. You see, a building that is net zero, that's one level lower than net positive, means a building that does not take more energy from the surroundings, does not kill one fish more, or does not kill one squirrel more, or something like that, or kill one more tree than what it was originally. And that's good. That's really good because we're not even there now. Most buildings are net negative. Yeah. But this word regenerative, I think for the building industry, it is a little bit in the future, but we're very happy and proud to say that top architects in the world and people really care when you think out of the box, yes, how do you get a net positive building? Okay, you can get a net positive building, for example, by making a farm, a vegetable farm on the roof of the building or on the facade of the building, right? You can actually have a chicken farm, you know, or a cow farm. Let's have cows, you know, in the building, in an urban high-rise building, right? So that's one way. That adds to food production. That is a net positive, right? And in terms of energy, to take nothing, obviously you have to not just generate the energy that the building uses, but a net positive means you can contribute the excess energy to the electrical grid. You can actually sell the electricity to your neighbors, for example, right? And in terms of water consumption, right? I think for water, it's very hard to generate more water than what you already have. So basically, you collect the rainwater and you save our rivers from flooding, because from this rainwater you collect and you use it to drink, for the people to drink, right? And you use it to flush your toilets and all that. Okay, one thing I would like to talk about, one other example is actually like land reclamation. You see, nowadays, we reclaim a lot of land. If you look at the size of Singapore, Singapore is literally almost double the size it started off with, right? But the idea of land reclamation in the traditional way is to dredge sand from the sea. In that process, you make the seawater turbid and you kill a lot of fishes and sea life, right? And then you take it and then you dump it in the sea and cause more turbidity, but you have land because human beings are at the top of the pyramid of life, right? So we have this power. Okay, so engineers, structural engineers, geotechnical engineers, today we have the knowledge, the technology. All we need is the will and the drive and the passion to create more land, but don't take from the sea, right? So of course, then it becomes like a puzzle. How do you create land without taking from the sea? Okay, I won't give you the answer to that question, but those are some of the things that we need to think about. I hope I answered your question.
Fair enough. Yes, you did, and questions to ponder for the future as well. Now, one final question, obviously, and this is a big question that's been talked about, bandied around for in recent years and probably for years to come. IR 4.0, the Industrial Revolution 4.0. What does it mean to you and to the structural engineering industry as a whole? Could you share?
Sure. Okay, I will start off with kind of like the expected answer. I mean, of course, it's a correct answer, but in a way, it's expected. And then I'd like to go a little bit deeper than that first answer. Okay. Now, Industrial Revolution 4.0 is actually very well defined in structural engineering and in the building industry, right? Like, for example, we all work with three-dimensional modeling using programs like Revit, building information modeling. We build, which means the mechanical system, the architecture, the structure is all put together in one 3D model, computer model, so that during construction, it's a lot more efficient. There are less clashes, there are less cases of pipes banging each other here and there. That's like simple, right? And in terms of design, of course, we have the tools. We have all kinds of computer modelings too. I could model the chair you're sitting on, Raj, if you're sitting on the chair, right? And I can tell you whether I can improve that chair structurally or whatever, So we can model anything. We can model even the nest of termites, yes, so that we can study whether there's any structural lesson to be learned from termite. So all this is to do with hardware, is to do with programming, is to do with software. So that is one thing. The second thing is that AI. We can use robots and we can use augmented intelligence to do a lot of precast components for buildings, right? Instead of having like 1,000 low-skilled workers in a construction site, lifting heavy things, for example, or doing a lot of manual tasks, the components instead come already prefabricated, and we just like a Lego set, just put them in their place on the construction site. So to a lot of people, that is the answer to the question. What does IR4 mean to the building industry? But you see, this answer comes with it certain other questions, and this is the part I said I hope to talk a little bit more about this. Okay, so you save carbon dioxide and you save carbon emissions and you save all this embodied energy because you have all these tools. And you don't need to carry so much concrete, you have less vehicles on the road. Let's say you do all that. But don't forget the meaning of sustainability. It also means that you have to sustain a craft or you have to sustain a skill. What happens to the construction worker, the 1,000 construction workers who were carpenters, who were doing manual work, right? That's actually a skilled work too, like putting timber together and stuff like that. They may be out of a job. They will be out of a job, right? Because you don't need them anymore. You can just put them together. All right. So when we do all these things, right? We are going to repeat. Okay, this is my personal feeling. I think we are going to repeat the mistakes that we did in the 20th century. In the 20th century, we have factories. When we have factories, then we don't need the artisan anymore, right? We need to bring back the artisan. And so for this example of sustainability, I like to look at Japan. Japan. You see, if you realize, if you actually read a bit, it's interesting because Japan is a very advanced country, and yet in their cities and in their towns and in all their homes, right, they keep the traditional arts. We started this talk talking about a mud wall. The Japanese were building this wall made of mud and straw in Japan instead of made of concrete, right? But this mud wall needs to be rebuilt, like when it rains, right? Or every year, at least it needs some maintenance. I met this man in Japan who is a maker and a repairer of these mud walls. And for a few generations, his family has always been making mud straw walls. To me, that is the meaning of sustainability. You sustain a craft, you sustain a livelihood. And these are the things we have to think about. It is not so much making everything to be made by robot or whatsoever. Because human beings, we need a job. There are 7.7 billion people in the world today. It will become like 10 billion in 30 years, right? I mean, You see, during this lockdown period or MCO period, the people who can work remotely from home, if you realize, are people whose jobs are intellectual, are people who can work with the
Yeah.
thing. But if you're talking about someone like who works with his hands, right? Let's not forget them.
Obviously, the evolution of industries over time, and of course, there will be those which are lost. There'll be new jobs that be created thanks to technology and advancement. And I guess, end of the day, to summarize, it's all about balance. That we don't forget the past. We should still keep that as something that that makes us human, rather than relying purely on technology, robots, AI, or things that that come in that form.
I don't, not, okay, in a way, yes, but also a little bit more. A little bit more, I don't think we want to keep it just as a heritage or just as
Mm-hmm.
some good things of the past or put it in a museum. I think
Mm-hmm.
it needs to be alive. And I think there are a lot of things that we can learn from the crafts, from what the artisan and from the craft. And I think this is something that we, you see, if the 20th century is definitely the age of physics. You know, I said I love physics. That's the age of
Mm-hmm.
physics, right? We get all this nuclear power, blah blah blah, right? But the 21st century and what we live today, it is the age of biology. We are going to learn from nature, and today the tools that we have is actually to teach us more about nature and about the craft and about the artist and about the artisan. So, as a structural engineer, um, I try to be extremely conscious of all these things in the design that we do. It sounds like it's hard to merge it, but that's what we try to do.
All right. On that note, Pek Har, thank you so much for your time today and talking about building for a better planet. Your insights has been most invaluable.
Okay, thank you, Raj, for letting me talk. Okay.
No worries, no worries. And speaking about IR 4.0, we will be leading up to IR 4.0 Regenerative Nation Forum, which will be taking place right here on ESG TV very, very soon. So for our viewers, do stay tuned for that. My name is Raj Arya, ending today's webcast session. And remember to play your part to make Mother Earth a better place to live in. Take care.